Hi YouTube, Timothy Unkert here. In this video, I want to look at simplifying fractional exponents. So I have this generic exponent here with a base of x, and then the exponent part is this fraction a over b. Well, a is the number of times, so a is, let me put this in a different color, the number of times you would multiply the base together. And actually, let me just write this out. So the number of times you multiply the base together. Okay, and the bottom part here, this part, is going to be the root of the base. So this is the root of the base. Okay, so I think this is best looked at in terms of some actual examples with numbers. So let's go ahead and do that. All right, in this first example, we're going to be simplifying the exponent 3 raised to the 3/2 power. So the top number is going to be the amount of times that we multiply the base here by itself. So we're going to have, well, three threes. So we're going to do 3 times 3 times 3. And then this bottom number here is going to be the root. Okay, so this is the second root or the square root. So we could just do a square root sign. Occasionally you'll see a little 2 here to indicate that it's a square root. I'm just going to keep with the square root sign as we work this out. So let's do first 3 times 3 is 9, times 3 again is 27. Okay, so we get 27. And we're going to take the square root of 27. So one way we can think about this is, well, how can we break this apart? Well, this 3 times 3 is 9. Okay, so what we can do is we could break this apart into the square root of 9 here times the square root of 3. Well, the square root of 9 is 3. So this is going to equal, let me just do this in blue now, 3 square roots of 3. And that's as far as we can go for simplifying this fractional exponent. Okay, in this next example, we're going to simplify the exponent 4 to the 3/5 power. Another way we could write this is we could write this as the 5th root of 4 cubed. So I'm going to write it as the 5th root of 4 cubed. So what is 4 cubed? Well, 4 cubed is 4 times 4 times 4. So the 5th root of 4 times 4 times 4. If I multiply 4 times 4 together, I get 16. And then we're going to have 16 times 4. That equals 64. So we can write this as the 5th root of 64. Now, if you do have some number sense, you notice that 64 is 2 times 32. And we want to break it into the 5th root of 32 because that is an integer. So we take the 5th root of 32 times the 5th root of 2. And that simplifies. The 5th root of 32 is 2 because 2 to the 5th power is 32. And so anyways, the 5th root of 32 is 2. So we have 2 times the 5th root of 2. And that's as simplified as we can get for this particular example. All right, in this example, we're going to simplify the exponent 8 to the 2/3 power. This is the same thing as the cube root of 8 squared. So I'm going to write this as the cube root of 8 squared. So that's the same as the cube root of 8 times 8. Well, 8 times 8 is 64, so this is the cube root of 64. Now, interestingly, if we do 4 times 4 times 4, and I think we saw this in a previous example, we get 64. So therefore, the cube root of 64 is just plain old 4. And we've simplified this exponential expression. Okay, I think we're going to do this as a last example. So we're going to simplify the exponential expression 9 to the 4/3 power. So that's like the cube root of 9 to the 4th power. So let's write the cube root of 9 to the 4th power, which is 9 times 9 times 9 times 9. Okay, so 9 times 9 is 81. This is also 81, so we have 81 times 81. Okay, so 81 times 81 is, let's see, we have 81. If we do 1 times 1, 1 times 8, then 8 times 1 is 8, and then 8 times 8 is 64. So this works out to be 65, 61. Now, if you've seen my video on divisibility rules, let's add this up. Actually, let's first write it as now the cube root. Fix that. The cube root of 65, 61. So if you see my video on divisibility rules, if I add up these numbers, so I have 6 plus 5 plus 6 plus 1, well, that's 11 plus 6 is 17 plus 1 is 18. So I can, because 18 is divisible by 3, I can divide this number by 3. So I'm going to take 65, 61. Oh, I keep writing it like that. And divide it by 3, so 3 goes into 6 twice. So we have 6 here. That leaves 0. We bring down the 5. 3 goes into 5 once. So 5 minus 3 is 2. Bring down the 6. 3 goes into 26 8 times. So we get 2. We bring down the 1. And 3 goes into 21 equally 7 times. Okay? So another way we could write this, let's fix this a little bit. We could write this as 3 times 2187. And let's get rid of this stuff now. Okay, interesting thing about 2187 is 2 plus 1 plus 8 plus 7. Well, that also equals 18. So 2187 is divisible by 3. So let's take that. So now we've got 2187 divided by 3. So 3 goes into 21 7 times. So 7 times 20, sometimes 3 is 21. So we get 0 here. Bring down the 8. 3 goes into 8 twice. 2 times 3 is 6. 8 minus 6 is 2. Bring down the 7. And 3 goes into 27 evenly 9 times. So we get 729. So if we want to go here, we can write this as 3 times 3 times 729. All right, well, let's take a look at 729 now. Let me move this stuff out of the way. Get rid of all this stuff. Well, so 7 plus 2 plus 9, well, that's also 18. So 729 is divisible by 3. So let's divide that out. So 729 divided by 3. 3 goes into 7 twice. So we get 1, bring down the 2. 3 goes into 12 evenly 4 times. So 12 minus 12 is 0. Bring down the 9. And 3 goes into 9 evenly 3 times. So we can subtract 9 here. It's 0. All right, so if I continue to break this down here, I'm going to have now 3 times 3 times 3 times 243. Okay, so if I break this apart, I have a cube root of 3 times 3 times 3 times the cube root of 243. So the cube root of 3 times 3 times 3 is just 3. So we have 3 times the cube root of 243. Now, interestingly, 243 is, well, we have 2 plus 4 is 6, plus 3 is 9. So 243 is divisible by 3 as well. So let's try and break that down further. See if we can get it even further. So take 243 divided by 3. Well, that's going to be 3 goes into 24 8 times evenly. 24 minus 24 is 0. Bring down the 3. 3 goes into 3 once. So we're left with remainder 0. So what I can do is, let's simplify this a little further. So this is going to be now 3 times 81 right here. Well, 81 is, if I add 8 plus 1, that's 9. So that's divisible by 3. So let's keep going. All right, so change here. Let's do 81 divided by 3. So 3 goes into 8 twice. 2 times 3 is 6. 8 minus 6 is 2. Bring down the 1, get 21. 3 goes into 21 evenly 7 times. So 7 times 3 is 21. Remainder is 0. Okay, so we can start to break this down even further here. So this is going to be 3 times 3 times 27. Okay, now 27 is 2 plus 7. That's divisible by 3. So we can keep going. So that's not what I want to draw. I don't want a square root sign. I just want the division symbol. So I got 27. Divide that by 3. Well, 3 goes into 27 evenly 9 times. 9 times 3 is 27. So remainder 0 here. So I can break this down further into 3 times 3 times 3 times 9. Okay, so if I want to keep breaking this apart, this is 3 times the cube root of 3 times 3 times 3 um, times the cube root of 9. Well, again, this is 3 times the cube root of 3 times 3 times 3 is just 3. So this becomes 3 times 3 times the cube root of 9. Now, the cube root 9 is 3 times 3, but we are looking for a cube root, so we really can't break 9 down. But we can multiply 3 times 3, so that's 9. And we have 9 times the cube root of 9. Okay, we probably could have gone about an easier way of simplifying this by dividing by 9, but I thought it was kind of cool to break it down by threes. I like dividing stuff by 3 to break up my square roots. Might take a little bit longer, but it's kind of a fun process. Anyways, hopefully this video helped you out. If it did, please like and subscribe, and thank you for watching.